we know how to encrypt, I'll show you how to decrypt. There are two ways: brute force and the non-plain text attack. Brute force is where you manually compute or calculate from one alphabet to the possible ciphertexts, and the second method is where we use a formula. For that reason, we use the second method. So for us to use the plain text attack, we need at least two pairs, each consisting of a plain text mapping into a ciphertext. So for illustrations, we'll use I mapping into P, F into Q. Now we'll have two equations using the same formula where the ciphertext is equals to alpha multiplied by the plain text plus beta. Okay, so this will be the first equation. This is the value of P, the value of I. Okay, when they obtained after you arrange from A to Z, A being value 0, Z being 25. So you can substitute so that you can eliminate one unknown and be left with just a single unknown. So -1 is equals to alpha 3. To avoid dealing with negatives, you can add 26. Remember, we are using more 26 since the English alphabet or language has 26 alphabetical letters. So yeah, you can add 26 to get 25. So 25 more 26 is equals to alpha 3. You can divide by 3 both sides to remain with alpha on one side. So 25 is equals to, remember, we avoid working with fractions and decimals, so we write it as the inverse of 3, because 1 over 3 is the same as 3. Yeah, so now we use the Euclidean algorithm so that we can find the inverse of 3 without having to, so that we may not end up working with decimals or fractions. So that's how you write the equation. So applying the Euclidean algorithm, 26 is equals to, so we say 3 goes into 26 8 times, the remainder is 2. 2 goes into 3 once, the remainder is 1. 2 goes into 1, the once, the remainder is 0. Since the remainder is 0, that means that the GCD of 3 and 26 is 1. So now you work backwards. 1 is equals to 3 minus 1 times 2. This 2, you can substitute it. Because you had a 2 here, you need to have 2 on one side. So we'll take this 8 times 3. On the other side will remain 2 is equals to 26 minus 8 times 3, which is the same. Then after substitution, we'll find that x is equals to 9. So now 9 is the value of, is equals to 9, and y is equals to -1. But y can vary depending on what you want. You can have 9, or y can be -1 plus 26, which is 25, depending on what you want. But x, which is 3, which is the inverse of 3, that's a constant. So now you'll have alpha as 25 times 9, which is 225 divided by 27. You'll get a number, but the remainder is 17. So alpha is 17 mod 26. Now you have one of the requirements of the key, which is the alpha as 17. Now you need to find the value of the beta, which means you'll take one of the two equations. For my case, I chose 15, which is equals to alpha 9 plus beta. Since we already know the value of alpha, which is 17, you just input it right over here. To get 17 times 8, it should be plus. But now you'll have to have beta on one side, so you'll take 15 minus this. Take this on the other side. You'll use a modular arithmetic to simplify this equation. So 17 is equals to -9 mod 26. I'm sure you know how to do it, because 17 minus 26, the remainder is -9. So that's how we got the modulus of 9. Yeah, so we just substitute in here, open the brackets, we get -72. -72 is equal to -20 mod 26. Now substituting with what we know into this equation, we find that 35 is equals to 9 mod 26, so the value of beta will be 9. So now for our key, which comprises of alpha and beta, is equal to 17, and so this will be our key, our encryption key. And that brings us to the end of our presentation for both the encryption and the decryption. Thank you.